All right, hey guys, so this is going to be the wrap up for that story problem example. We were talking about small and large tables. So there were 6 people per small table and 10 people per large table. And we needed the total number to be at 180. We found our x and y intercepts. Our y intercept was 0, 18, and our x intercept was 30, comma 0. So now we were going through and trying to figure out yeah, sorry about that. I was just double checking our numbers in my head. So now we had to go and graph the line. Now graphing the line isn't the easiest thing because this graph is so big. Now I'm going to do a little cheat for myself because I know a couple more points that are on this line. You guys would not know them yet, but on your paper, you should be able to always connect the 2 dots, okay? So I'm just gonna put in a couple more points that I know are on this line. 10, 12. And let's just go to 20, 26. So now that I know these points are on here, it just makes it a little bit easier to graph. You would not have those points yet, so just bear with me while I make my graph look nice. Some of you guys might have a question about what I'm doing right now. And if you do, I would say you're on the right track. Because someone's probably saying, Mr. Whaley, why in the world are you connecting those points? And you would be correct. You know, learn how to draw a little bit better. But these points should not be connected. It does not make sense. Remember, this is a discrete problem. We were talking about tables. You cannot buy a part of a table. So it is not continuous, it's discrete. What that means is we only have certain points that work. I drew the black line. This is my theoretical line, okay? This is, if every point worked, this is what I would have. But remember, the only points that work are whole number points or lattice points. You can only have whole number tables. So that's what I'm looking for right now. So you look, it looks like the first one occurs at 5:15. Another one occurs at 10:12. Another one occurs at 26. And then the last one will occur at 25:3. Okay? So let me try to make these a little bit bigger for you so everybody can see. I'm going to write down their values also. So this first point was 0, 18. This one was 5, 15. This one was 10, 12. This one was 26. This one was 25, 30. The final one was 30, comma 0. So as we look at all these points, these are the only points that really should be on our graph. There may be one more at 15.9. I can't do that in my head. It looks like it would make sense to have another point right there. And let's check. If 15.9 is on our graph, I don't know this one, so I'm going to put it in blue right now. 15.9. Well, remember, this would be a solution for this equation. If it's a solution, I can plug it in, it would be true. So 6 times 15 plus 10 times 9 would have to equal 180 for this point to be on our line. So 6 times 15, that is 90. 10 times 9 is 90. 90 plus 90 is 180. So since that is true, that point must have been on our line. So 15.9 is another point on our line. All we did was find different table combinations to seat 180 people. That's what this whole line means. The black part of the line is irrelevant. It's the red dots that matter. Remember, this should be a discrete graph. So what does each point mean? 0 small tables and 18 large would work to seat our 180 people. 5 small and 15 large would work to seat 180 people. 10 small, 12 large would work to seat 180 people. I hope this is getting pretty redundant because it is redundant. This is not meant to be some mind-blowing fact. This is meant to be just different options. And then you would have to take this information and make the best decision possible for how do you want to seat people between small and large tables. So remember the whole point of this problem. 6 people can sit per small table, 10 people can sit per large table. We need to seat 180 people. What combinations could we have? The lattice points from this line are our possible combinations. And one that would work the best, that would be up to you. So thank you guys very much. Continue on to the monitoring progress.